Hello and welcome with something interesting, something very you were looking for. As I've just mentioned that I am now jumping back to the origin of organic chemistry, that is again from the peak to the bottom. From the starting of the organic chemistry, that is of course, last time I was discussing hydrocarbons with you. So what are hydrocarbons? Of course, the compounds that contain carbon and hydrogen in them are called hydrocarbons. Now further, I told you that hydrocarbons are further subdivided into the two forms, that is the aromatic hydrocarbons and the aliphatic hydrocarbons. Okay, and of course then the aliphatic comes from the Greek word, that is aliphatos, that means that contains fats, right? And that carbon containing long chains, right, or chains that you will learn, and that has got aliphatic groups in them. Okay, so now the aliphatic hydrocarbon also consists of three other main families, that is alkanes, alkenes and alkynes, right, which I've mentioned earlier. And alkanes, if you start from alkanes, I've discussed with you different aspects of alkanes, and in the example, the simplest alkane is methane, which I have explained, right? So today I thought that I should start with something interesting, that is unbranched alkanes. What are unbranched alkanes? Unbranched alkanes are the alkanes that has got no branches in them, that are not cyclic in structure, that have no rings in them, they are straight chain compounds, right? So straight chain compound means they are in the form of straight chain, a carbon, again a carbon, again a carbon, and a carbon. They are connected to each other, right? And in a straight chain. So that is why they can be called as normal alkanes, right? The straight chain alkanes are also called normal alkanes, right? And if you normal alkanes are even abbreviated as N-alkanes. If somewhere you see it's written as N-alkanes, you will simply say it's normal alkanes. So now you should learn the names of the first 12 unbranched alkanes, starting from methane, ethane, propane. I can show you right now here. Okay, now, so I was just telling you about the different, the unbranched alkanes, right? The first 12 members which you are supposed to learn. So first is the methane. And if you give the heading, that is compound name, and of course the molecular formula of the compound, and then the condensed form, the condensed structural form. Even you can write it like this, condensed structural formula, right? So this is the condensed structural formula. So for methane, if you start from methane, what would be the molecular formula? Is methane is CH4, whereas this condensed formula would also be CH4. If you talk about ethane, that has got two carbon atoms, it would be like this. Molecular formula would be C2H6, whereas its condensed structural formula would be CH3. You can count the number of carbons here also and hydrogens here also. Carbon 2, 1, 2, and hydrogen 6, 1, 2, 3, 4, 5, 6. So yes. Propane, third member, C3H8. Its condensed formula will be CH3, CH2, CH3. If you count the carbons and hydrogens in them, they will be equal to this formula, right? Then the molecular formula, condensed formula, would be equal to the number of hydrogens, and carbons would be equal in the molecular formula. Okay, so if you talk about butane, it is C4H10. Now, how you are going to write CH3, CH2, CH2, CH3. Now, there is another way. You can put CH2 because you have to, write CH2 for 2 times. So you can put close it with a bracket, the CH2 group, and you can put a small 2 here. 2 means that you are going to repeat this CH2 for 2 times. 2 times, right? So that means this is called the condensed form, CH3, CH2, CH2, CH3, right? So this is the for butane. Fine. And this I have written here also to make it more clear. CH3, then this is CH2, CH2, and CH3. Okay. If you talk about pentane, then its molecular formula is C5H12, and its condensed structural formula will be CH3, CH2, 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 that is 3 times, and then CH3. right? And if you talk about hexane, it would be C6H14. And what would be its formula? Condensed formula CH3, CH2, 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 right? 4 times you have to write CH2 and then CH3. This is the condensed structure formula. And again, if you will start counting the number of carbons here, number of hydrogens, and you will match them with this, it would be C6H14, which is for hexane, right? If you write heptane, it would be C7, right? Heptane means C7H16, right? C7H16. So what would be its condensed formula? CH3, CH2. You will close the bracket. And you will write for about 5 times. And then you will write down CH3. This would be like this, right? So this would be like that, okay, right? So this is the condensed formula for this heptane, right? This is it. And the same pattern you will follow for octane. That is octane means 8. That is, what is the molecular formula of octane? C8H, how much? H18, right? So in the same way, you are going to write down the condensed formula for this, right? So the condensed formula for octane would be C8H18, right? H3CH2. And how many times you will write down CH2? You will write it down for 6 times, right? And then CH3. This would be your octane. Okay, and then of course you will come with nonane. Nonane. What is nonane now? Nonane is C9H20. C9H20. And you will write down in the same way the condensed formula. I hope now you understand how to write the condensed structure formula and how to write the molecular formula. So basically, alkanes are represented by a general formula, right? And I mentioned also in my previous lecture that it is CnH2n plus 2, where n is the number of carbon atoms, the carbons it holds in a chain, right? In a straight chain or whatever, right? And the structural formula, what is structural formula actually, right? It is actually a molecule, it's Lewis structure, right? The structure formula is its Lewis structure. So what does that Lewis structure shows? It shows the connectivity in which the atoms are connected to each other, in which the atoms they are connected in either in this direction or that or some other direction, but this shows the connectivity, right? Or the order in which they are arranged. It shows the order of atoms also. So for example, if you see an example of hexane, right? It's a straight chain compound, right? And it has got its formula is CH3, CH2, 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 and then again CH3, right? So this type of a formula, if you write the molecular for hexane, that does not show you its geometry, right? It just tells you about the connectivity, how the carbon and hydrogens are connected to each other by the covalent bonds, right? And sometimes when it becomes very longer, it's difficult to write, we take help of the condensed structural formulas. We condense it down and write it in the condensed form. Now, if I would write down the compound that is hexane, right? If I make its structure, what it would be like? Of course, 6 carbon atoms, 1, 2, 3, 4, 5, and 6. And then I will write down the hydrogens. I will connect the hydrogens with it, right? It would be like this. It would be like this, and every bond, it has got a hydrogen in it, right? So what it would be like? CH3, CH2, again CH2, then again CH2, then again CH2, and then CH3, right? This would be like this. So now here, this simply the straight chain of this hexane, it shows us, the connectivity of carbon and hydrogen bonds together, right? But it does not show us the geometry. Now, and it's time consuming, right? It is, it's very time consuming to write down each carbon and then the two hydrogens, again the carbon and the two hydrogens, the carbon and the hydrogens. So just to save up the time also, we use this condensed form of that same structure, right? That is CH3, CH2, 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 and CH3. If you count the carbons here and if you count the hydrogens here, they will be equal to this one, right? This is the same thing. So in such a structure, the hydrogen atoms are understood now to be connected. They are connected how? To each other, right? The carbon atoms are connected to it with hydrogens and via single bonds, all the single bonds. And sometimes even these bonds are omitted, right? And so that you can say hexane can also be written as simply like this, or you can simply write it like this: CH3, CH2, 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 and then again CH3, right? So this is also the same thing that you can also write it like this, okay? Just to show the not to show the bonds between them. The bonds are omitted here, right? So this is something the way how we write different forms, right, to save up the time. And these are all unbranched alkanes, right? These are the series in which there is no branching, there is no cyclic structure. And now a series of compounds that differ only by the addition of methylene group is also called a homologous series. Is also called a homologous series, where there is a whereas there is an exception that differ by the addition of a methylene group. What is a methylene group? CH2 group, methylene group, right? So that is called a homologous series. So that's it. So my dear students, today I explained you what are unbranched alkanes after going through the series of alkane series, and after explaining you different physical aspects of alkanes, even that is its solubility, its melting point, boiling points. And then I jumped into the next section, that is the unbranched alkanes and the straight chain alkanes that shows the connectivity, and there's no geometry is being given there or shown there. It's only the connectivity of atoms. And then I explained you what are the condensed structural formulas. If you have to save up the time, we use the condensed structural formulas. We even sometimes omit the bonds between them, and we write down without the bonds how does they look like. And I gave you the example of hexane molecules. So I hope you understood this topic today, that is what are unbranched alkanes. So this was unbranched alkanes. This was something new topic for you, for those who are the beginners level, who have not are familiar with these things, right? So please try to understand this topic and try to follow it. Find a good book. You can use Jerry March, you can use Vogel, you can use you can read this Loudon, you can use Solomon's Frall. These are all the 4 or 5 books that are very good for any organic chemistry student. I don't prefer the Indian authors or the different national authors. I would prefer the international authors, because you need to you learn everything with the authenticity, right? That everything is authentic and everything is real. So I hope you understood today's lecture, and you will learn it, you will like it, and you will share among with your friends, and go through them and learn them properly by referring these books which I have just mentioned in this lecture. Hope to see you again very soon with something again. This the continuity of these hydrocarbons series, because it's quite a long topic. So I will be discussing with you the other things also. So let's see you again. Thank you very much. Bye bye.